In this video, I'll explain the 5 rules of inferences, explain what they are and how we use them to do derivations and proofs. A rule of inference is really just another way to say a valid logical form. So our 5 rules of inference here refer to 5 different common valid forms: the disjunctive syllogism, the hypothetical syllogism, the modus ponens, the modus tollens, and double negation. Since these 5 are all valid logical forms, we could prove that using a truth table. And so for each one of these, we would find that there are no rows where both of the premises are true and the conclusion false. Another way of saying the same thing is that if the premises are true, we also know that the conclusion is true. That's why it's called a rule of inference. So to explain further, let me just go through each one of these. Let's start with the disjunctive syllogism. I'll just rewrite it over here. Our first premise of the disjunctive syllogism is a disjunction, P or Q. The second premise is tilde P, or it's not the case, P. And our conclusion is Q. This is a valid form. This is called a disjunctive syllogism. Why is it valid? Well, we could do a truth table and we can show that on any row where the premises are both true, the conclusion would also be true. In other words, there would be no case where both premises are true and the conclusion false. This is not possible with the disjunctive syllogism. I think the easiest way to understand why this is a valid argument is to start with the second premise. The second premise, for the second premise to be true, this whole sentence, the negation of P, we know that P therefore has to be false. But we know that for a disjunction, for that to be true, we need at least one side of the disjunct to be true. So knowing that P is false, we therefore know that Q must be true. And that's why you're never going to have a case in a disjunctive syllogism where both premises are true and the conclusion false. What that means for our purposes for derivations is, let's say that you are given premise 1 and premise 2, and the question was, well, what can you derive from premise 1 and premise 2? That is, if premise 1 and premise 2 are true, what else do you know must be true? Well, you know that Q must be true. Why do you know Q must be true? Well, if premise 2 is true, you know that P is false. And if premise 1 is true, that means Q must be true. That's why you're able to derive Q from premise 1 and premise 2. Now let's look at how this might appear in a derivation problem. So we're used to the form of a disjunctive syllogism as looking like this. P or Q, it's not the case P, therefore Q. But if faced with a derivation question, such as this, and you were being asked, given lines 1 through 3, that is, given premises 1 through 3, what can be derived from those? We're used to thinking of the disjunctive syllogism in this form, but remember, this form can appear in a lot of different ways. So what do we have? Premise 1 over here is tilde A. Premise 2, if D then F. Premise 3, D or A. Well, our disjunctive syllogism is hiding in premises 1 and 3. They're just flipped around a little bit. Rows 1 and 3 are a disjunctive syllogism. So just as we can derive Q from P or Q tilde Q, we can derive D from the negated A and D or A. Remember, it's the form, not the order of premises. So it might be a little bit easier to recognize it like this, where we put D or A, not A, therefore D. So to do derivations, you're going to need to be able to be familiar with the generic form and also how it might appear in a more complicated set of claims. So cleaning this up a little bit here. We are able to derive D using the rule of inference disjunctive syllogism based on lines 1 and 3 and justifying it DS for disjunctive syllogism. Let's move on to the hypothetical syllogism, which has the form of if P then Q, if Q then R, and if both of those are true, we know that the conclusion, if P then R, is true. If we were to construct a truth table, we would see that there would be no lines or no rows of the truth table where premise 1 was true, premise 2 was true, and the conclusion false. So again, we'd have no row, which is another way of saying, for this argument, it's not possible for this argument to have true premises and a false conclusion. And here's why. The hypothetical syllogism forms a type of chain where the consequent of the one conditional claim is the same as the antecedent for the other conditional claim. The way we know a hypothetical syllogism is valid, that is, you'll never have a case where the premises are both true and the conclusion false, is because of the way that the Q works here. So let's say that we wanted to see if this could possibly be the case where the conclusion is false. The only time a conditional is false is when the antecedent is true and the consequent false. So that would be the only way. So let's see if we can plug those in and be consistent with those truth values. So if premise 1 were true and P is true, that means Q could not be false because we need to have this whole premise to be true. So if P were true, Q would need to be true, which brings us down to premise 2. If Q is true, then R has to be true. So we could not have this situation. So this is a valid form of argument, and it can be used as one of our rules of inference. So let's take a look at how that might look in a derivation. We should be able to recognize the general form of the hypothetical syllogism over here on the right. If P then Q, if Q then R, what follows from that, or what must be true from those are, therefore, if P then R. But if you were faced with a question that asks you, what can be derived from these three lines if S then P for premise 1, R or P, premise 2, and then 3 if R then S? Well, we've got two conditionals and a disjunction, and while we might recognize the hypothetical syllogism in this form, we might not be able to see it over here, but it is in fact the case over here. They've just moved around a little bit. Remember, what we're looking for are those chain linkages. Over here it was Q. But remember I said the hypothetical syllogism works such that the consequent of one conditional is the antecedent of the other conditional. And that's what we have here. The consequent of this conditional is S, which serves as the antecedent for this conditional. So just as we can derive if P then R from this hypothetical syllogism, we can derive if R then P from lines 1 and 3, justified through the hypothetical syllogism rule of inference. So what that means is we need to become very familiar with how this form, the hypothetical syllogism, can show up among different claims. Remember, the hypothetical syllogism, the validity of it has nothing to do with the order of the premises. It's that this form is valid. So even if we swapped these premises places, or we swap them like this, it's still a hypothetical syllogism. It still has the same form. So what you can derive from that works the same way. Another valid argument form is called the modus ponens, abbreviated by MP. Since it's a valid form, it becomes one of our rules of inference. So let's explain how it works. Just like the disjunctive syllogism, let's start with the second premise. If the second premise is true, that means P is true. If P is true in premise 1, and the whole statement is true, then Q can't be false, because that would make the statement false, so Q has to be true. Well, you just showed how Q follows necessarily from the truth of premise 1 and premise 2. Now let's take a look at it in a derivation problem. The modus ponens is pretty easy to recognize over here, but if you were presented with a derivation problem and I asked, what can you derive from premises 1, 2, and 3, you might not recognize that there is a modus ponens hidden in here. So just remember, this is the generic form of it. So let's take a look and see if we can spot where it exists over on the left-hand side for the derivation. Well, we've got a conditional, and this is a conditional. Here is in essence, our P term, and here is, in essence, our Q term. Here's the equivalent P, this whole thing. And so we do have this form. It just is organized differently, and it's got all those tildes, but it's going to work the same way, such that we can derive tilde B from lines 1 and 3 using the modus ponens rule of inference. So to show you again, here's our conditional, and we can see in premise 1, tilde A is our antecedent. So tilde A, if tilde A then B, well, we've got tilde A, and by the rule of the modus ponens, which we just showed, that if you have the conditional and the antecedent is satisfied, then you get the consequent. We just have to be used to not just recognizing the generic form and the P and Q, where you have the conditional on top, then the affirmation of the antecedent in the second premise. You have to be able to recognize it among a set of other claims, including when you have the antecedent or the consequent being negated, because it's this whole term is the antecedent. This whole term, including the tilde, is the consequent. And the antecedent shows up here. Let's do the modus tollens next. The modus tollens argument form is also valid. And it looks a bit like the modus ponens, but it works a lot differently. So you'll want to understand it and be able to recognize it. So let's show why it's not possible for this argument to have true premises and a false conclusion. So let's see if we can make this conclusion false and the premises true. If the conclusion tilde P is false, P must be true. So premise 1, if P is true and the conditional is true, then Q must be true. And if Q is true, and we want to make the whole premise for line 2 true, there's no way we could do that with Q being true. That is, we can't make tilde Q true and Q true at the same time. So this just is not possible. So it becomes one of our rules of inference, known as the modus tollens. Another way to think about that is if you have a set of claims where one is a conditional, another one is the negation of the consequent of that conditional, you also know that it's necessarily true that you get the negation of the antecedent of that conditional. So let's take a look at it in a derivation problem. So on the right, we can recognize the modus tollens, but would we be able to recognize it among these three claims? So if you were faced with a question that says, given premise 1, premise 2, and premise 3, what can be derived from those three claims? We might not recognize a modus tollens in here, but it is in fact in there. So let's take a look at that. Here's a conditional. Here is the negation of the consequent of that conditional. And so we get the negation of R. That is, tilde R can be derived from lines 1 and 3 using the modus tollens rule of inference. So be sure to be able to recognize the general form of modus tollens and understand why the conclusion necessarily follows from the premises. That is, given if P then Q, the negation of Q, the negation of P is necessarily true logically, but also to be able to recognize it existing among a series of more complex claims, where again, the order doesn't matter, it's the form that matters. And on the right here, you have premise 3, which is the conditional, premise 1, which entails the negation of the consequent of that conditional. And so you're able to derive the negation of that antecedent of that conditional in 3 using the modus tollens rule.